Okay, let's look at our problem set for subtracting unlike denominators and unlike fractions. Generate equivalent fractions to get like units, then subtract. So what common denominator could I use here? Well, here I could see that 3 can multiply to be 3, 6, 9, 12, 15, so on. 6 can multiply to be 6, 12. Oh, I already found a common denominator of 6. So this one gets to stay 5, 6, but I want to change 1/3 to have that common denominator of 6. So 3 times 2 is 6. So I'm going to make that still equal to 1, and 1 times 2 is 2. So now my problem becomes 5, 6 minus 2, 6, which gives me 3, 6. I would accept 3, 6 as an answer, or I would accept 1/2, which if I reduce it, I get 1/2. So either of those answers work. Either one works. Okay, let's look at this one. Here I can just multiply my two denominators, so I'm going to get a denominator of 6. 3 times 2 is 6. Multiply by that giant 1. Multiply by that giant 1. 2 times 3 is 6. 1 times 3 is 3. 3 times 2 is 6. 2 times 2 is 4. The 2/3 came first, so we're going to write 4, 6 minus the 1/2, which is the 3, 6, which gives me 1, 6. 1, 6. Here, let's do our common multiples. 6 can be 6, 12, 18, so on. 4 can be 4, 8, 12, so on. I found a common denominator of 12. So I'm going to do 5, 6 times my giant 1 to get a denominator of 12. 1/4 times my giant 1 to get a denominator of 12. 6 times 2 is 12, so 5 times 2 gives me 10. 4 times 3 is 12. 1 times 3 gives me 3. So now I have 10 twelfths minus 3 twelfths, which gives me 7 twelfths. Once we have a common denominator, we can simply subtract or add the numerator. Okay, let's see. Fill in the box to make the expressions equivalent. 7/8, 7/8. 1/4, oh, we don't have the 1/4 equivalent, and then the 1/2 and the 4/8. Let's see, we know 7/8 equals 7/8, so that one's done. We need to make 1/4 equal something that has a denominator of 8. 1/4 equals something that has a denominator of 8. So I look here, 4 times what gives me 8? 4 times 2. Multiply the numerator by the same thing. 1 times 2 gives me 2. So that missing number is 2. Let's just finish by double checking. 1/2, can 1/2 become 4/8? Yes, it can, by multiplying by that giant 1 by 4/4, and we get 4/8. So that missing number there was 2. Number 3, Sandra says that 4/7 minus 1/3 gives us 3/4. Because all you have to do is subtract the numerators and subtract the denominators. Convince Sandra that she is wrong. You may draw a model to support your thinking. Well, hopefully by now we know that she's wrong. We can't subtract them unless they are the same size pieces. So, you may draw a model. Okay. So, let's see. If I have a model here, well, this is 3/4. 1, 2, 3. This is my 3/4. And they're saying when I subtract 1/3 from 4/7, let's see, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And I subtract this with this, I'll get something bigger? That doesn't make any sense to me. No sense at all. 3/4 is bigger than 4/7, so that does not make any sense. So, we cannot get a bigger difference than what we started with. Okay, the correct way to do this, I would just multiply these and get a common denominator of 21. So we'll do 4/7 to equal a denominator of 21, my giant one. And we'll do 1/3 to get a denominator of 21. 7 times 3 is 21, 4 times 3 is 12, 3 times 7 times 7 is 21, 1 times 7 is 7, 12 21st minus 7 21st gives me 5 21st. Okay? 5 21st is the difference. Did I answer the question? Because all you have to do is subtract the number. Convince her that she's wrong. You may draw a model to support your thinking. Okay. Mr. Penman had 2/3 liter of salt water. He used 1/5 of a liter for an experiment. How much salt water does Mr. Penman have left? Does he have left? Okay, so what am I going to be subtracting here? I'm going to take that 2/3, what I started with, and I'm going to subtract that 1/5. In order for me to do that, I need a common denominator, which we could just multiply those two to get a common denominator of 15. And let's make those equivalent fractions. We're going to multiply by our giant 1 here. Multiply by our giant 1. 3 times 5 is 15. 2 times 5 is 10. 5 times 3 is 15. 1 times 3 is 3. 10 15ths minus 3 15ths gives us 7 15ths. Mr. Penman has 7 15th liter left. Last problem for us. Katrina needs 3/5 kilogram of flour for a recipe. Her mother has 3/7 kilogram of flour in her pantry. Is this enough flour for the recipe? If not, how much more will she need? Well, 3/5 and 3/7, those are not the same. And I know by comparing my fractions, I have the same amount, but I have the same amount of smaller pieces. So this is not quite going to cut it. So if this is what I need, this is what she's giving me, how much do I need still? How much more? How much more is a phrase that we often have for subtraction. Let's get that common denominator. Let's just multiply those and get a common denominator of 35. Multiply by our giant 1 of 7/7. We get 21 as our numerator. 3/7, again, our goal is 35. Multiply by our giant 1 of 5/5, and we get 15 on top. 21 35ths minus 15 35ths gives us 7 35ths that we still need. 7 35ths reduces, if I divide top and bottom by 7, I get 1/5. So, this is not enough flour. She will still need 1/5 kilogram for the recipe. That's it for today. Thank you guys for hanging out and watching.